Hi, this is the recorded demo of IoT security project. For detailed experiment setup and a step-by-step explanation, please see the description area below before you continue this video. The laptop is standing in for an IoT device with a static profile. It's running DHCP client, and the link to the profile is attached to the DHCP discover message. After we start our learning scripts, our system receives the DHCP messages. It picks up the extension, downloads the profile from a web server hosted outside, verifies its authenticity, parse it, and save it to our database. The web application is then notified to impose the profile. The web app triggers the ONOS controller to deploy the correct flows. The web application receives a message of device joining the network, which is our fake IoT devices, and it starts a scanning process. And here our device has a actual field of IoT and a static profile field in the database, and the web application will be responsible to talk to ONOS controller and send him the parsed profile. In this case, Amazon.com is the only domain in our profile which has this set of IPs 176.32.103, and it's the only domain whitelisted. So after the access control is imposed, we pings the IP address to Amazon, and it succeeds, but the ping to 8.8.8.8 does not go through.
This is the SDN demo for the static profile of our project. Now let's clear out the existing flows in the ONOS GUI. So as you can see on the right hand side, the flows have been cleared. Now in the network topology on the ONOS GUI, as you can see that for the router which has the IP address 192.168.86.1, its MAC address is 60.327.9b44bf, and for the device with IP 192.168.86.51, the MAC address is 001F3B052AC9. Now by default, the ONOS SDN controller enables layer 2 forwarding for the devices in the network. So as you can see on the right hand side in the ONOS GUI, layer 2 forwarding has been enabled for the device with MAC address 001F5B052AC9. So as you can see from these two flows, the layer 2 forwarding has been activated for the device. So on the ONOS GUI, as you can see, the ONOS SDN controller has activated by default the layer 2 forwarding for the device which has MAC address 001F3B052AC9. Now as you can see in the network topology, the port number which is connected from the devices to the switch is port number 2, and the port number from the router to the switch is port number 1. So as you can see in the ONOS GUI on the right hand side, for the layer 2 forwarding between the router and the device with the MAC address 001F3B052AC9, the input port is 1 and the output port is 2. And similarly for the forwarding between the device and the router, the input port is 2 and the output port is 1. Now if you want to see the list of switches which are present in the network, then the command which can be used to list the devices, list the switches, is devices. So as you can see, the switch which we have configured in the network has been highlighted. Now if you want to see the list of devices in the network, then the command used to do that is hosts, and as you can see the different parameters for the IP address 192.168.86.51 has been highlighted, and similarly the different parameters for the router has been highlighted. Now if we want to enable layer 3 routing for a particular device, then we need to add a particular flow for that purpose. So as you can see in the last flow in the ONOS GUI, the source address has been specified as 192.168.86.0, which is the subnet of the IP address of the device for which we want to enable layer 3 routing. And if we want to enable layer 3 routing to a particular website, for example like facebook.com, so you need to specify the subnet of the destination IP address, which in this case is 31.13.69.0/24, which is the subnet of facebook.com. So after adding this flow, layer 3 routing is enabled, and this enables access to a particular website like facebook.com. Therefore, the whitelist has been implemented for the device 192.168.86.51, which has a static profile.
First, we'll show you our learning stage of the system. The left terminal connects to our default gateway, which is Raspberry Pi turned SDN switch, and the two terminals on the right connects to our Ubuntu machine, which is the local node in our network. It fixed as a IoT devices. It talks to Amazon.com every 5 seconds. After we start running the learning scripts, we have two devices joining the network detected, and the events are sent to our web application. The web application receives the messages and starts to processes to scan the hosts. Back to our control screen. During the learning window, the live traffic will be parsed and used to populate the database. At the same time, every 10 seconds we'll save the traffic and upload it to Dropbox. A separate process running machine learning training system will download the traffic file and starts training the system itself. Back to our web application, we are almost finished the scanning processes. In our shell terminal output, we can see there are two processes finished. One ends with 51 IP addresses, and one ends with 62 the IP addresses. And now we are going to show you the monitoring stage, part 1, endpoints anomaly detection. We will use our IoT device to talk to Facebook. As soon as we start monitoring and the device talks to Facebook, we have anomaly generated. And our web application receives the anomalies. It passes the anomaly messages and talks to Ono's SDN controller to add the flow rules to block the communication. Since we're using two generic laptops as IoT devices, there are a lot of noisy communication running in the background, which are seen as anomaly too. The flow rules is added, and the communication to Facebook is blocked now. As seen from our web application, there are lots of flow rules added, and it's still passing the anomaly message in the message queue, and let's wait for it to finish. After the web application finished passing all the anomaly messages, we'll see those two hosts are compromised. And during part 2 of our monitoring stage, we'll show you that we can use our machine learning model to detect a behavior change even though the endpoints are valid. Here we had a failure because the network is disrupted due to the failure of the Raspberry Pi. The devices are disconnected.
This is the SDN demo for the dynamic profile part 1. So in this case, when a device accesses a malicious endpoint, then the access to that endpoint is blocked. So essentially, a blacklist is a list of bad endpoints for which the access for a particular device is blocked. So now let's implement the blacklist for the device with the MAC address 001F3B052AC9. Now as you can see, in the end 3 flows have been added and they help in implementing the blacklist for the device. Now for implementing the blacklist, we have to ensure that the access to a malicious endpoint is blocked, and the last 3 flows in the Ono's GUI help us in implementing the blacklist for a particular device. Now as we can see in the second last flow, in the treatment instructions it says no action, and this ensures that if you want to block access to a particular domain, then the packets which are going to this particular domain will not reach the gateway, and this is ensured by no action in the treatment instructions. And therefore, in this way, the access to a particular domain like facebook.com is blocked for the device which has MAC address 001F3B052AC9.
This is part 2 of our monitoring stage. We show you that we change the frequency of our communication even though the IP address is in the profile. And we use our machine learning model to detect the behavior change. The IP address 13.32.237.195 is associated with the domain amazon.com, and now we are pinging it every second. Since our model for the time of this project is not properly trained, so there are not a lot of noisy anomalies generated too.
This is the SDN demo for the dynamic profile part 2. Now in this case, the machine learning model understands that if a device pings a particular device with a different frequency, then it detects an anomaly. Therefore, in that case, the device is quarantined. So as you can see in the second and the third last flow, the access of the device to the gateway is blocked, and therefore the device is quarantined.